Uh, I was letting you know that using the previous procedure, you can generate the standard values of your variable of interest over here. Then what you need to do next, when you have created your standardized value as a step one, in the next step, you need to go to the last column of your data with a view with which you are showing your z value of your variable. Just right click and sort descending. All right, we need to right click on our variable of interest, that is our variable of interest, that is the last column that we have generated. We just need to right click over here and we need to click descending, sort descending. You just need to click it and you will find the highest value over here. If this value is greater than 3.3, it means there is an outlier appearing in that value. But if this value is less than 3.3, it means there is no outlier. So in our case, there is no outlier in this data. We can check the same procedure over another data. For example, let's suppose uh, previously I have entered 221 over here. If I need to check this using the same mechanism, uh, go to descriptive, then again descriptive, then I need to put income over here, then I need to check this option, and I need to click OK, and you will find values like this. Then what next? I need to click over here, right click and select sort descending, and you will find value 3.09. And you can see here the criteria is plus 3.3 or minus 3.3. Still this value is less than this range. So we can conclude over here that this value this value is basically not a significant outlier. But let's suppose this value is something much bigger. Let's suppose it is 321. Let's suppose. So we need to recalculate it again by using the same procedure: analyze, descriptive, then click OK, and you will find the values like this. And you can see the value, the highest value. If I click it like this, you can see the highest value which is in front of 321 is 3.38, which is greater than our criteria 3.3. So we can see that here is the way of pointing out the outlier. So the higher number will always appear against a number which is an outlier. So there is a procedure: either we take an average of the number using the all remaining number, or we can simply remove it as an outlier. So these are the method of detecting the outlier from your data. So I hope three of the methods you have cleared very well. So I have considered the outlier detection, and in detail you have understand. And this was also explained. So remedy if outlier detected. If outliers were detected, what to do next? Whether we can take it, we can keep it, or we can remove it. So there are different strategies that you can apply if outlier is detected. The first strategy is that make sure the outlier is not the result of data entry error, because sometimes we have entered our data in some haste or some hurry, and we have made some wrong entries in our data set. So you need to verify with whether there is a wrong entry, or whether some of the responses are out of the range due to wrong data entry. So you need to verify your data entry. Sometimes an individual simply enters the wrong data value when recording the data. If an outlier is present, first verify that the value was entered correctly, and that it was not an error. The second thing is remove the outlier. If the value is true outlier, you may choose to remove it if it will have a significant impact on your overall analysis. So if you find an outlier which is extreme outlier, and you think that it can impact your results, you need to simply remove that outlier. Just make sure to mention in your final report or analysis that you removed an outlier. The third thing that you can do with the outlier, if the value if the outlier turns out to be a result of data entry error, you may decide to assign a new value to such as the mean or the median of the data set. As I have mentioned you earlier, that you can take the mean of the remaining data set, or you can take the mean of the remaining values of that particular column to generate your value in place of the outlier value. So these are the method you can apply when your data has some outlier. So what is next? Next is the last assumption that we need to deal, and after this, we will move towards basically the regression cases. The last assumption for our today's session is uh, testing the testing the absence of heteroscedasticity. Our main assumptions is that there should be a homoscedasticity in our data. And what do we mean by homoscedasticity? Homoscedasticity means equal variance at all levels. So when there is an equal variance at all level, that condition is considered as homoscedasticity. For for a reliable analysis, for an efficient estimation, we need to have homoscedasticity in our data. But if homoscedasticity, but if the homoscedasticity condition is violated, we may consider it as a heteroscedasticity, which makes our analysis, which makes our estimations poor, not reliable, or biased. So you need to check whether your data contains homoscedasticity, which consider our model as a satisfactory model, or your model contains some heteroscedasticity, which consider it as a unsatisfactory model. So in case of heteroscedasticity, the variance of your data may not be equal at all levels. In case of homoscedasticity, the variance are equal. In case of heteroscedasticity, the variance are not equal. So the variance of the residual should be constant across all level of the independent variable. In other words, the spread of the residual should be roughly the same throughout the range of the independent variables. So you can use scatter plots of the residual against the predicted value. If spread of the residual is roughly constant across all predicted values, homoscedasticity is assumed. So you need to take basically the scatter plot of your residual values. You cannot take the dependent or independent variables. You just need to take the residual. You can take the predicted value on one side and residual value on the other side to have a scatter plot, and then you will find whether you have homoscedasticity or heteroscedasticity in your data set. There are two methods you can apply to identify the heteroscedasticity, whether the heteroscedasticity is absent or present. There is a graphical method you can apply. You can go to the analyze, regression, linear, put your DV and IV in the required places and click the plot button. Now put the Z prediction in x-axis and Z residual in the y-axis. Z residual basically it is the standard residual value, while Z prediction value is the standard prediction value. So you need to put the standard prediction value in x-axis, and you need to put the standard residual value on the y-axis. So check the boxes of histogram and normal probability plot, continuous, and then finally okay. Now check the scatter plot shape. So first we need to apply this procedure using graphical method. Let's suppose that I have a data set Let's suppose I have a data set like this. I need to remove it first that I have created. Let's suppose I have a data set like this. I need to go to, if we see the procedure, we need to go to analyze, then regression, then linear. All right, and put our DV and IV in some places. So go to analyze, regression, linear. We need to put our dependent and independent variable. For example, these three are independent variable: final, total, and percentage mark. And this is our dependent variable. What we need to do next, put your DV and IV in the required places and click the plot button, and put the Z prediction in x-axis and Z residual in the y-axis. So we need to go to the plot button, that is a plot button. We need to put Z prediction in the x-axis and Z residual in the y-axis, and we need to check these buttons. Click continue. And, all right, you need to check normal probability plot and histogram. We have already checked them to see if other options are open or not. We need to uncheck the remaining parts. Only model fit and estimates are there. And from the plot side, we have put it Z residual and Z right over here, and histogram and normality need to be checked. You need to see this. There should be unchecked all the options. All right. There is nothing you can change from here and nothing from the style box. Just click OK and you will see a result like this. Just wait for a minute. The graphs will appear. So it has generated the graph. The first graph is the histogram of your uh, residual, and it is showing that there is a there is a normality of your data, but we don't need to check it. For our assumption of heteroscedasticity, we need to check the scatter plot. This is the scatter plot we need to check. Basically, the requirement is when you click OK, you need to check the scatter plot shape. So the scatter plot shape is there. This is a scatter plot between the standardized residual value and the regression standardized predicted value. So this is basically the graph between predicted value and residual value. And what it is showing, we cannot conclude over here that there is no homoscedasticity. We are still unsure whether we can conclude the homoscedasticity or heteroscedasticity, because according to the guideline, the homoscedasticity should look like this, like I have mentioned, and heteroscedasticity should look like this. And this output is showing a picture like the second one, but we are still unsure about it. So how can we be sure in exact figure? How can we basically sure whether there is a heteroscedasticity in our data or not? So there is a procedure which is basically non-graphical procedure, and this procedure is known as Bruce-Kagan procedure, and you need to understand this procedure because it requires three steps. By default, the SPSS does not have any command or any menu function to perform the Bruce-Pagan test, but the other softwares like Stata, eViews, and other softwares have this function. They can test the Bruce-Pagan test as a part of their menu bars, but SPSS doesn't have it. So how can we estimate the Bruce pattern using SPSS? So there is no direct procedure to estimate heteroscedasticity using Bruce pattern test in SPSS. However, we can indirectly estimate this test in three steps in SPSS. As a first step, you need to estimate the residues, and secondly, you must take square of the residue and make it squared residue. Then thirdly, you will run regression to test heteroscedasticity using Bruce-Pagan test. So I have basically uh, put these three steps in a more clear way. You can see you need to go to analyze, regression, and then linear, because as a first step, you need to create residual. So you need to go analyze, regression, and linear, then put your DV and IV in relevant parts. Use save button for generating residual as a standardized. So how can we do this? Just you just need to simply go to analyze, go to regression, go to linear. So what you need to do is you need to put your dependent variable over here, and you need to put your independent variable over in their relevant places. Now what you need to do, you go to the statistic, and you need nothing to do over here. You go to the plots, and you need nothing from here too. You just put back them, just uncheck this. You go to the save button. Yes, this is basically the part that we require for bootstrapping test. So in this box you need to check the standardized residual score, because as a first part we need the residuals. The first step is to find out your residual. So in the first part you need to put your dependent and independent variable, and you need to check your standardized residual score. So you need to click continue after checking this, and you need to click OK, and you will find that a residual will appear in your data view. You can see the data view. If you can horizontally move your horizontal bar, you can see that a column has been appeared over here as a standardized residual of your dependent and independent variable. So what we need to do next, this is the first step that we have computed for our study. Next, we take the square of our residual, the residual that we have just computed. We need to take the square of that residual, and for doing this you just need to go to transform, compute variable, write SQR, which is basically the short form of square residual, in the target variable, and write your variable name multiply by your variable name, which is basically your residual variable name, and it will create a square. So how can we apply this process? You simply need to go to the transform. You need to click compute variable button. You write here the name of your target variable, square, which is the square of residual, SQR, and you need to put your residual over here, that is the residual. You need to double click here, and it will automatically come in the numeric box. Then you need to multiply your residual variable with on self or with itself, and for doing this you again need to double click the variable, and it will appear here. So in this way you can create the square of the residue. So after doing this you just need to click the OK button, and you will find another column, which is SQR. This is basically your square of your residue. So we have applied the second step. So in second step, we have taken the square of our residual. So what we need to do, the third step is that take your square residual as a DV and regress it by taking same IV that you have used in step one. So what independent variable I have used in step one will be utilized in this step three, but this time the DV will be changed. The DV will be squared residue. So I can apply this third step over here. Go to analyze, go to regression, go to linear. You just need to replace your dependent variable with the square residue that we have computed so far. You need to put it over here while the independent variable will remain same, and you need to uncheck the previous procedure. You need to uncheck this, otherwise it will create the standardized residual again. As the standardized residual is not required in the third step, so you need to uncheck this, and you need to click OK button, and it will generate the table like this. So how can we identify whether there is a heteroscedasticity or not? So you need to see the ANOVA table actually. If the sig value of ANOVA table is less than 0.05, it means there is heteroscedasticity in your data, and your assumption of homoscedasticity is being violated. So this is basically the conclusion. As the regression is basically run on the squared residual of the data, so we can conclude from the ANOVA table, if the sig value of ANOVA table of our regression is less than 0.05, it means there is an heteroscedasticity in our data, and our basic assumption, which is there should be an homoscedasticity, is being violated. But if this value is greater than 0.05, if the sig value of ANOVA table is greater than 0.05, we can conclude that there is homoscedasticity in our data. So in our case, there is an heteroscedasticity. So we can conclude here that there is an heteroscedasticity. You can see the decision criteria in the last line. You need to check the ANOVA table after model summary. If the sig value is greater than 0.05, it is homoscedasticity, which means that assumption is met. But if the sig value is less than 0.05, it is heteroscedasticity, which means assumption is being violated. So this is the way you can apply this procedure on your data set. I have told you the graphical procedure, and you have learned a lot from this procedure. So it was about how you can estimate your different assumptions. So the last thing regarding the assumption, after which I will start the different cases of regression. The last thing I will like to make you clear about it, that using SPSS, you can estimate the first six assumptions. I have cleared the linearity, normality, and independence of error in my yesterday session. While I have cleared the multicollinearity, outlier, and homoscedasticity in my today's session. So whenever you find some discrepancy in your analysis, in your simple or multiple regression analysis, you need to check linearity, normality, independence, multicollinearity, outlier, and homoscedasticity assumptions. If something is wrong with your data, you can identify whatever the wrong is with your data using these assumptions, and you can accordingly correct your estimations. So that someone contacted me in today's morning and told me that his regression results are not significant. He has the secondary data, and he has estimated the regression, but he find out that his results are not significant. So I suggested him to please check the assumptions of regression, whether your data is linear, whether your data is normal, independence, multicollinearity, outlier, homoscedasticity. So you need to check these assumptions. If the assumptions are fulfilled, the results are okay. But if one of the assumption, or more than one of the assumptions are being violated, you need to make corrections. You need to go to the remedial measures of correcting your data, so that your results could be considered reliable results. The last two assumptions are basically related to the secondary data, which I will let you know whenever I will teach you this data or the e-views, because these two assumptions would require a secondary data like time series, like panel or cross-sectional data. So these assumptions are not required when you are using SPSS. In case of SPSS, you just need to check the first six assumptions. So this was about the assumptions related to regression. Now I would like to take a 10 minutes break, and I will start then basically the different types of regression, the cases of regression over here, to make you understand how you can apply the procedure. Till then, you can ask any questions related to today's discussion or yesterday discussion in the chat box, and take a 10 minutes break. So we have less than 1 minute, and you need to rejoin again. So I'm writing a message over here. So I am saying again that the meeting is going to end. So you need to join again using the same link so that we can start the 10 cases of regression, and some of the cases we can complete today, and the remaining cases we will continue tomorrow along with the haste process. So you need not to worry about the remaining cases. So you are requested to join again using the same link after the meeting ends.